This is my DIY drawing robot, and in my last video I added magnetic encoders to it, which made it a whole lot more accurate. Now while it's a whole lot more accurate than the last model, it still draws jerky lines due to a few things. Starting with the pen mount. The pen mount used to be one of these little clothes hanger clips, and while it made it super easy, there was quite a bit of wiggle room in there, which made the drawings look super jerky and not quite right. Now the time between uploading that last video and now has been around 2 weeks. Unfortunately, I had some things come up that I had to take care of, but during that 2 weeks, I tried to fix this problem. I started by making this new type of pen holder that allowed you to fit basically any pen size in, and it held it a lot more straighter than the last one. This did seem to improve the drawing effect quite a bit. However, it required bigger bearings and stuff to hold it on to the end of the arms, which made that whole arm section there a whole lot heavier, which then caused the pen to like drag on my paper and kick it up here, as you can see. Now, I thought a way to fix this would be to add support legs. I had support legs on an old version, however, I decided to remove them because they were kind of getting in the way, but I added them back to this version and they sucked. They did add extra support to the top there, but the feet on the end of the legs were just plastic, and it had a ton of friction on the paper, which caused them to grab the paper even more. Also, it's kind of hard to find a good spot to mount the legs because they get kind of in the way of the homing process. I think it'd probably be better if we had legs that had little wheels on them, but I'm not entirely sure. Anyways, with that, you're basically caught up to where I am right now. I'm gonna take a little break from working on the pen stuff, and I'm gonna start working on the actual user interface of this. Currently, we're using these buttons right here to move the arm up and down, left and right, and all that stuff. And then I also have an extra button, which just automatically draws whatever shape I have programmed into it. But as you can tell by the wire mess that we have right here, it's really hard to get back around here and push the buttons without unplugging something. Also, it's kind of hard to draw different shapes by just pressing a few buttons. So I want to fix this. And to do that, I want to use this. This is a Python library called Streamlit. Basically, they make it super easy for you to create cool UI designs. I've used these in past projects before. As a matter of fact, if you've seen my smart shoe display video, I use this to make a user interface for debugging the shoe display. It plugs right into Python, which is what I'm using, so it's super easy and it makes pretty good looking UIs. Now, my idea is to make a UI that's kind of like this, but it has like a little plot on it that shows where you can and can't draw. And then it has it so that you could enter in points, and then it'll kind of automatically connect the points together so that you can draw pictures, if that makes any sense. Ultimately, it'd be really cool if we could upload a picture and then have it somehow decode the picture into a bunch of points that's got to go to, but I'm not entirely sure how I'd do that yet. However, I want to get the manual point setup added to it, which still should be a whole lot better than the current button setup that we have right now. Now, before we start working on the UI, I first want to test out a few things which should make this thing a little bit better, starting with a angle correction function that I made. In my last video, I talked about how this thing moves by calculating how much steps each motor has to take to get to a certain point or certain angle. However, with the setup that we had before, it'd first calculate the steps and then start running through them. And then once it got through all the steps, it would then go on to the next angle. However, that did not account for any steps that were skipped or missed along the way, which meant that if it skipped any, it would just think it made it through all of them and then start working on the next one, and that slight error could throw it off over time. So what we're gonna do right now is send the update to it and see if it works a little bit better. Should start homing. For some reason it's not. All right, there we go. All right, so the update has now been sent to it, but I'm not entirely sure how we should test this right here. What I guess we can do is probably try to draw a rectangle right here and then put my hand in front of one of these things to see if I can get it to stop moving or skip some steps. Theoretically, it should try to keep moving this until it gets to the right angle, but I'm not entirely sure if that's going to be a good test because these things here can sometimes spin without actually skipping a step. This one here is probably the tightest one since it has glue, but let's just give it a shot. Okay, it's gonna come back up. Let's see. All right, so I can clearly tell that this arm right here is moving without it actually skipping a step. Like, for example, see I'm turning it right there, and I could push it and leave it, and it's not actually turning the shaft. It's just the arm that is turning. So, man, I wish these motors had a little cutout in the shaft. This side over here doesn't even have any glue, so. All right, I'm not gonna worry about it too much right now. I don't think it's too big of a deal, but I wanna go and test something else. All right, so I got another function that I wanna test, and that's a reachability function. You see right now, it can only go out to about this far right here. Anywhere in this zone that my hand is in, it can't reach. And it also can't reach down around where the motors are down here. And so I have a function that checks to see if the coordinate that we want it to go to is in any of those regions. And if it is, it should quit the program from running. And then also, kind of hard to see, but there's a small blue LED right here, and that should light up as well. So let's turn this thing on, send the update to it, and see if it works. All right, the code is sent. And before we test an invalid point, I first want to test a few valid points, starting with this one, and it should go somewhere right here. Okay, yeah. Let's try the second one. Should go some point over here, I believe. Oh yeah. And then I think we have a third one, and that one should be up here, I believe. Okay, well, it wasn't that quite that far. Okay, that's all good. Now, we're gonna test the invalid point. Here we go. Oh crap, okay. Dude, okay, it should have done a check first. Let me see what the heck's going on here. All right, I checked out my code. There was a small bug in there. I don't know why it even worked for the right ones, but it did. So anyways, we're gonna try this again. Let's first move to our first point. Okay, second point, third point, okay, and here's the wrong point. Boom, didn't move, that's good. Also, if we look over here, you can see our blue little LED is on. If I press one of these buttons to go to a correct point, it should turn off. Yep, and the robot arm just moved. Okay, I'm gonna press the wrong point again. Boom, turned on, didn't move the arm. That is perfect. Perfect, perfect, perfect. Now, this is really good because it should help eliminate that problem that we just saw. You see, when it gets a point that it can't actually reach, it ends up getting an error in the code, which causes the motors to just spin out of controllably. And obviously, that's not what you want. And so this is really, really good. All right, there are just a few bugs left, but I think it's gonna be totally fine to move on to the UI. So let's go do that. All right, so here's our UI so far. As you can see, there is nothing here. We do have a title, but we need to make it so we can actually input some points so that they can get sent to the drawing robot. All right, so the arm is now on and we have our UI right here, so we can enter in our X coordinate and our Y coordinate. If we enter in our X coordinate, which is gonna be 0, 0, and our Y coordinate, which is gonna be 125.0, we should be able to send it to the robot. Okay, here you go, I'm gonna press the send button. Boom, all right. All right, so this right here works really good for getting the point and then sending it right to the robot. However, what we need to do is have it store the point so that we can add more points to it and then send it to the robot when we press the send button. So yeah, this is what the UI looks like right now. You can add in your X point, your Y point, and then right here it shows you all of the current points you have in. Right now we don't have any, so it's not showing any. You can then add the points, send the points, and then clear the points. So if we go ahead and add this point, you can see it just got added to the array right there, or list. Let's go 0.0, and then let's go 150. I don't even know if that's a possible point. This setup here does not have any reach verification, so if we add in a point that it can't reach, well, I guess the robot will catch it, but it would be nice if we caught it first before we even send it to the robot. So whatever, let's go add that point. Let's go 90, and then let's go with this is 75. Okay, so we have 3 points right there. I'm gonna go and press the send button now. Okay, interesting. Okay, yeah, that makes sense. So as you can see, it is moving. That's really nice. That means we can easily add points. Now, this is a lot easier to add points than it was before with pressing the buttons and stuff. But as you can tell, we can't even see where these points are. I have a rough idea where the point is gonna be just because I did all the math for it and I know how the chart looks, but it's kind of hard to visualize where 30, 100 is gonna be on the board. So what I wanna do is add something like this. This is a little graph here that I told Claude to make. Basically, it's just a visualization that shows the graph and then if your point is in a reachable zone or not. The red is unreachable, which means we can't have the robot arm go there, obviously. And the green is all good to go. Now, technically this one's not super accurate because I do have a limit right here, so it can't cross my finger right there. So it's basically only this top half that it can draw in, which that's not a whole lot of room, but it is what it is. However, I want to try to get something like this into our Streamlit UI and then have it also update showing the points that we add in. So let's see if we can figure this out. Now, while I was on Claude, I also decided to ask it how the heck we'd even do this. And it says we're going to have to use something called Plotly Charts, which Plotly is just another Python library, I guess. If you actually go to the documentation here with Streamlit, you can look up Plotly Charts and you can see all the stuff for it. So we're going to try to figure out how to do this. Okay, I don't know quite how this works. I gotta ask it how this works, but we had to switch this around and now we have this here. So you can see I can move this chart around and you can see there is a point right there. That's our 0, 125 point, 0, 125. And then we have another one at 0 or 30, 150. Double click to zoom back out. I like that. Let's go 20, 150. Boom, automatically adds it. That is sick. Oh. What the heck? We should have it draw a line to each point though. Lines plus markers. Toad, dude, take a look at that. If I can quit zooming in and out. Okay, now you can see a line from how the robot's gonna go boom to that point first, to that point, to that point. I'm just gonna press send. Yeah, okay. Now we've got to figure out how to show the zones that you can't go in. I'm not sure how we're gonna do that either. So we're probably gonna have to ask Claude again, I guess. All right, so it's the next day and I think I've got it figured out. As you can see here, the chart is now red and green. The green is where you can go and the red is where you can't go. You can also zoom in just like that. I think you can even make it, oh yeah, right there. You can even make it huge. Now, the way we created this was a little bit different than what I was expecting. This is actually the second attempt of doing this. The first one was really simple. Basically, what we did was just generated a ton of points, around 90,000 to be exact, I think, and then just figured out if they were reachable or not, and then gave them a red and green value depending on if they were or not. Now that was super simple, but as you can imagine, rendering 90,000 points takes a little while. And so every time you added a point up here, it would take a second to add it to the thing and then this thing would load and freeze up kind of. Now that wasn't too big of a deal. I think it was around 5 to 10 seconds of waiting, but it wasn't quite how I wanted it to be. I want it to be like instant. So I asked Claude how we could make it more efficient and it recommended these things called heat maps. Now, it might be a little bit difficult to see here, but basically what we do is we still generate a bunch of points. However, it's a lot less than before. And then we create these things called matrices, or a matrix, I guess, maybe. Now, we have two matrices. Anyways, we have two of them, one for all of the X values and one for all the Y values. We then basically put that into our reachability function up here, except it's not the same reachability function because we're using a different library to do the square roots and stuff. And somehow that is able to basically compute all of the values at the same time, which seems kind of nuts to me. At least I think that's how it works. It basically brings it down to the C level computing something. I'm not sure. That's what Claude said. What I understood is that it's no longer using a for loop in Python to check and see if all the points are reachable. It's instead going into C, which is another programming language for you, those of you who don't know, and it's somehow computing them all at the same time, or at least it's computing them a lot faster than it would be in Python. And so basically it does that, and then it creates another matrix, except this time this matrix is with all of the true or false values on whether it can reach that point or not. And then we bring that down into this thing here called a heat map, which then takes in all the values and all of the true or false values and then colors them red or blue, whether they're true or false. That's kind of the dumbed down version. I'm still trying to wrap my head around it because I haven't used Matrix at all before. Actually, I have, but it was a little bit different and I didn't really get into the weeds of it, you know? So it is a little bit new to me, but it works really good. For example, you can see this is our chart right here. I have a little blue point right there. Let's go add another one. Let's go 100, 200. Oh, whoops, I pressed sent instead of add. Okay, I'm pressing it. Boom, as you can see, it instantly added the point and then drew the line between them. If you zoom in here, you can see it's actually like a bunch of squares, and that's because I guess it's taking a point and then placing a square in the center of that point, or having the point be in the center of the square, and then it expands it out to the surrounding points. Now, while I was trying to figure out how this matrix stuff works, I thought of a potential idea for how we could add pictures to this theme. And it's very similar to how this thing here works. This is an e-ink display, and you could add custom pictures to it by first converting them to a bitmap and then uploading that bitmap into the special function they have on here. I can't remember what the function is called. That function then goes and reads the ones and zeros in that bitmap, which correspond to a white or black pixel, and that then goes and draws your image. Now, I was thinking we can make a function that's similar to this in the sense that we could have it so you could upload a picture. That picture then gets converted to a bitmap, which we can then use to figure out what coordinates or pixels have drawings in them or not. If they have a drawing in it, then we add it to a list, which the robot arm then goes and draws to. Now, I don't think this would be super hard to do, but I'm still just thinking about it, so I'm probably not going to add it in right now. We would definitely need something to lift up and down the pen, and then we would also need some kind of algorithm or something to determine where the start of the image is and where it needs to lift up and all this stuff, which I'm completely lost on how we would do that right now. But I thought it was pretty interesting how these matrices are probably the key to making this thing be able to draw custom images. Anyways, images aside, there's one more thing that we need to add, and that's linear interpolation. If you take a look at our graph right here, you can see that we have 2 points that are connected together by a line. Now, if we wanted to draw this line on our piece of paper with these 2 points, it would actually be kind of hard because the points are so far apart, and one of the motors is going to get to its required angle before the other one does, which means while the end effector does still get to the 2 points, the line going between them is going to be kind of wobbly. Now, the way that we fix this is by adding a bunch of little subpoints in between these 2 main points. That's what they call linear interpolation. And to do that, I added this function right here. This is our linear interpolation function. It's pretty simple. It just generates a bunch of points between the 2 points. We then store those points in a list and then add those points in the list to our new list. I also went and updated the UI to have this little slider right here. This basically just adjusts the percentage of points added. So for this, we're just going to keep it really small, around 4%. Let's add our first point in, and then let's add a second point down here. Boom. So as you can see there, I added 2 points, but it went ahead and added 3 other ones in between those points. Now, when we send this to the robot, it should draw straighter. However, there is still quite a bit of gap between those 3 extra points there. So what I'm gonna do is just erase this. We're gonna turn up the percentage a little bit, and then we're gonna add in our points again. So there's the first one, and here's the second one. Oh, whoops, knocked it down a little bit, but boom. It actually looks like a solid line, but if we zoom in here, you can see it's just a bunch of tiny little points in between there. Now that that's added, the line should be a whole lot straighter. Let's actually send this to the robot and see what it does. All right, I almost forgot, but we got to go ahead and glue on this arm to the shaft here, or else it's just going to keep twisting off. Let's add a little bit of hot glue in here. Oh, just got my hand in it. Okay. All right, that's not as good as I'd like it to be, but I think it'll probably do. Okay, I'm gonna press the send button here, and then I'm gonna hold down on the paper real quick. So here we go. Oh. Okay, interesting. We can ignore this little line here, but this was our line that was supposed to be pretty straight, and it looks pretty straight. It does look like it's curving a little bit, but then right at the top, it does this weird thing for some reason that's really odd. Let's try a different point. Okay, I've went ahead and drawn a new shape. This one's a square, and then it should go to around the middle of the square. So let's give that a test. All right, here we go. What the heck is that? Well, that doesn't look quite right. Let's try removing the linear interpolation, so having it generate like no points, and let's see what that does. Let's press that again. Here, I'm gonna check something real quick. Alright, so I checked the code to see if we had any problems with like the dimensions of the arms or anything, and there isn't. It all should be right, and I think I discovered the problem. I'm pretty sure it's just where these things connect right here. If you look, I glued that on, but it's moving. Same with this one. It's also moving, but the shaft is not actually moving from the motor. You can see there's a light here, right up there, that shows this all is on, and these things here should be locked up. I shouldn't be able to turn them, but since they're not turning there, when this thing here goes to move, it gets caught on the paper kind of like that, and the shaft keeps moving on the inside of these motors, so then it doesn't actually get to the right angle, which means we get these weird, not quite right drawings. I believe that's the problem, or at least that was the bigger problem. So I'm gonna go try and grind down a slot right here that this thing will lock into, and that way we don't have these problems. All right, so this is pretty interesting. The goal was to draw a square, 20 by 20 millimeter square. Obviously, it did not draw a square, but it drew a rectangle. As you can see right here, this is drawing a rectangle, I guess, with not so many interpolated points. So that little slider there, you can slide that up and get higher resolution. And that's what I did for right there, as you can see. And then I slid it up even more, and yeah, it does seem to be a whole lot better. It's kind of odd though. I don't know why. It looks like the whole thing is angled slightly for some reason. Technically it should be, now wait, maybe this was because my paper, here, just a second, let me try something here real quick. I'm gonna try making my paper leveled with the thing. So yeah, that is really weird. This theme does seem to be like angled off, which is really weird. As you can see on the chart right here, this square, I guess it does kind of look like a rectangle in here too. Anyways, it should be pretty leveled with the paper, with the edge of the paper right here. But as you can see, that is definitely angled for some odd reason. So I'm not sure why that's the case there. Now, I'm not a big fan of it being angled like this. If we want to draw pictures eventually, we're gonna have to get this problem fixed. So I'm gonna go and look into it and see, maybe I can figure out what the heck's wrong with this. Now, this took an extra day, but after doing a ton of testing, I thought of this idea of adding a little function to the drawing robot that allowed it to capture the actual real angle readings after each point move. So when it moved to a point, it would capture the angle reading and then move to the next point and capture the angle reading, and then so on and so on. With that, we can compare it to what it actually should be and see if it's actually doing what it's supposed to be doing. So that's what I did, and I made several charts to visually show what it looked like. All right, so we have my charts right here. These show the ideal motor angles and the actual motor angles of drawing a straight line across the paper. Now, as we saw during those tests, the straight line ended up being a big old bowl. There's nothing straight about that. So I took all of the angle readings after each point and then compared them to the angle readings that we were supposed to have. And as you can see, this is it. It's really weird. So this is for the left motor, and the ideal one starts at the top and then starts going down, and it goes down to here. Now, the actual one starts down here for some reason, goes up, and then it starts to get closer to the actual drawing over here, or actual angles, or ideal angles over here. Super, super odd. Now, if we compare that to our right motor angles, you can see they start really close at the top or at the beginning of the line, but then the further they go, the more they get pulled apart here. It's super weird. It's like the exact same thing, just mirrored and flipped. It's really weird. And so I'm not entirely sure what's the deal with that. I then went and also had Claude go and make me a forward kinematics function so we could actually put these angles back into there and see what X and Y points they give me. And this is what it came up with. So this is really weird. The line here, the red line, that's what we wanted to have, and the blue line is what we got. Now it's crazy how the blue line is, first of all, really curved, as you can see. That's really odd. Also, it's way up above the red line. This middle part here should at least be down here where the red line is. It's really crazy how far up there it is. And so there's definitely something going on here. I'm just not sure. I don't even know what to look for. So I'm probably gonna try to put this in the AI and see what the heck it can come up with. But it's super odd. Now, with being totally lost, I threw all of my data into Claude, and after a few minutes, it told me this. Basically, I was using the wrong ATAN. Inside of my Arduino code, I was using just ATAN, which only returns angles in the range of -90 to +90 degrees, which is not ideal, especially for this type of robotic arm setup. We need something to give us the full 180 degree spectrum. So we need to switch that out with ATAN 2. Now, the crazy thing is I even had this as ATAN 2 in my Python test function, which means I guess I just forgot to add it inside of our Arduino version. So I'm gonna get that changed and we'll see what it does. All right, updated ATAN. Let's see how this goes. Oh, geez. Okay, that's not supposed to happen. All right, I think I got the problem fixed. Let's see what this does here. Oh my goodness. Okay, nope. What the heck is up with this? Let me check this again. All right, I thought I'd changed the thing, but I didn't actually, so let's see if this works. Whew. Okay, good. Okay, let's have it draw the straight line that we told it to draw before. Oh my gosh. I think we fixed it. Look at how straight that is. Oh crap. Okay. What the heck? Dude, it was going just fine until halfway through. That was so weird. Okay, huh. All right, guys, I believe I've got it figured out. It took me several hours, but if we place a piece of paper right here, open up our pen tip and press send. Huh. Take a look at that. It's dragging the paper a little bit over here. Whoops. Oh my gosh. Dude. That is insane. Whoops. Okay. Forgot it did that. All right, so I just made it go back to the original point there, but ignoring this line here, you could see clear straight line. That is insane. That is the best thing we've drawn so far. Let's try have it draw another square again. Let's see what that looks like. All right, that's the square or rectangle, I guess, that we want to have it try to draw. So let's see what it can do. Okay, whoops, okay. Kind of a rough start there, but let's see what it does. This is a pretty big shape. Dude, it's basically perfect. We didn't get the pen up right there, but dude, check that out. Kind of hard to see it there. Oh, that's harder to see. Okay, well, I guess we'll just have to do this. Dude, that is insanely good. We should try to have it draw a triangle now. That's what it failed to do in the last video. All right, there's our triangle. Let's see if it can do that. Okay. A little rough there at the start. Oh, I gotta really hold this down here. Oh my gosh. Okay, a little rough there at the start, but that could just be the pen. This whole setup here, the only downside I see right now is the actual body design. There are some loose ends here that could be improved. As for the code side of things, that's really good. That is so much better than the last one we had. Here, let's try another shape. All right, here's a little hexagon for it to draw. That is so cool though. I can't believe that. I can't believe that. All right, so that's actually really insane. I'm really glad I took the extra time to go and try to figure out this problem. This video was supposed to be done yesterday, but I took an extra day. We got it figured out. I'm just blown away by this triangle right here. I tried to do this in last week's video, but it ended up not being super great. The hexagon, also, that's insane. It's just any of these curved or angled lines like this is pretty dope. Adding the whole linear interpolation setup really helped with this part right here. I want to see if this thing can draw a circle, but I need to make something to like generate a circle because it would kind of take a long time of just adding in the points manually, I guess. So I need some kind of circle generator, I guess. But I bet if we had it, it could probably do it. I think the only limitation to this thing now is the body of it. We need to get like tighter joints or whatever, and also experiment with the arm lengths. I feel like experimenting with that could maybe help us find a perfect ratio that doesn't have a lot of wiggle room in it. I'm not sure, maybe I'm just going crazy. This UI right here is also a huge step. It's now way easier to add in and test a bunch of different points. With the last versions, I just had to go and manually type them in on the Arduino side of things and then send it to it and then press the buttons, and oh man, it was a mess. But this here is a whole lot better. This is also my first time using Claude for something like this. I've been experimenting around with Claude and I thought it did a pretty good job this time. There were a few times, especially like a few hours ago, where it was just putting out straight crap. But it was actually really helpful. I was able to upload our charts. Speaking of which, these are the new charts for this new data for the line, and you can see it just lines up perfectly. This is the left motor right here. This is the right motor. It does get a little bit weird here, but that's because it goes below 0 or a negative number, and we have to kind of do some trickery, I guess, to kind of switch it around to positive number for the right motor to actually reach to. This is also the line. Now this looks really weird, but I think it's right. I think our Y value is just zoomed in a ton for some reason. I don't know why it looks like that, but in reality it does draw the line pretty straight. Anyways, I was able to put in these charts into Claude along with all of the other code, and it was able to just go through it and figure out what was wrong, especially the ATAN symbol. I was using just ATAN, where I guess I needed ATAN 2 because we are only getting a range of -90 to 90 degrees, and we needed a -180 to 180. I don't know if that makes any sense, but we needed to do that, and it was able to spot it. I don't know how I didn't spot that before when I was adding it in. I had it in my Python example file, but whatever. This project has been a whole lot of fun. Despite that, I think this is going to be the last video. I was kind of getting bored of working on this thing before I figured all this stuff out. I think this is going to be the last one, and I think it was a good way to end it off. We got everything fixed, figured out. I'm gonna go ahead and upload all of this new code to GitHub. So if you guys want to build this thing, there's a link down there with all of the CAD files, the code, all of that stuff. I don't have a schematic on the electronics, unfortunately, so you're just gonna have to figure that out. But it's all there along with all of the links that I used. I was able to find some stuff on this type of robot last night, so I'm gonna try to include that as well. Feel free to look through it. I think this was a really good learning experience right here. This robot was way better than my first one that I made over a year ago. And the main goal of this was to figure out how inverse kinematics works. And I think we've got a pretty good understanding of how it works now. If you guys like this video, make sure you go and hit that like and subscribe button. And also, like I said, I'm gonna be leaving all of the stuff for this in my GitHub in the link in the description. And so if you guys wanna check that out, feel free to. I tried to write a lot of the code myself, but obviously, like I said, we did try to use Claude here in the end. So there is gonna be some AI written code. But yeah, with that, I'll see you guys all in the next video.